Complex conjugate. Any complex number a plus bi, where a and b are real numbers. The complex number a minus bi is called its complex conjugate. When you multiply a plus bi and its conjugate a minus bi, the result is a squared plus b squared. Here's the proof. When you multiply a plus bi with the a minus bi, use the distributive property like the Fourier technique that you learn in algebra class. A times a, we get a squared. A times negative bi, we get negative a times bi. And the inner part, bi times a, we get plus side a times bi. Last times last, we get negative bi quantity square or b square I square. And then the two terms in the middle, they cancel out. Now we have a square minus b square. And recall that I square is the same as negative 1. Therefore, the result from the product of the a plus bi and its conjugate is a square plus b square. Let's look at the example. We use the complex conjugate to simplify the expression when the denominator is in the complex form. In this case, the denominator is 5 plus I, which is 5 plus 1 times I, or a is 5, b is 1. Therefore, the conjugate of the complex number 5 plus I is 5 minus I. Then we're going to use the complex conjugate to multiply top and bottom of this expression and put in the parentheses here. So 5 plus I on the bottom, and then multiply by the conjugate 5 minus I. Top and bottom, 5 minus I. So this is multiply. So the denominator, the product becomes the a squared plus b squared, where a is 5, so 5 squared, where b is 1, gonna be 1 squared, and the numerator gonna be the product of the two complex numbers. Use the distributive property again. 4 times 5 is 20. 4 times negative I is negative 4i. 3i times 5 is positive 15i. And the last term times last term becomes negative 3 times I squared. And then we just simplify further. The denominator becomes 25 plus 1 or 26. Numerator 20. The two terms in the middle simplify to be positive 11i. The last term becomes negative 3 times negative 1. Recall I squared is negative 1. And then clean up the numerator. Now we get 20 plus 11i plus 3, all divided by 26, which is the real and the real combined to be 23, plus the complex or the imaginary term 11i divided by the denominator 26. So we get the standard form of the complex number for part A. Let's look at the second example. This one, as you see, the negative power can be rewritten as the reciprocal of the positive power. In this case, the complex number we have has the a 3 and b 5, so the conjugate is 3 minus 5i. From the original expression, we multiply numerator and denominator with the conjugate 3 minus 5i. And after that, simplify. Numerator is 3 minus 5i divided by the bottom, which is the product of the complex number and the conjugate, where a is 3, so gonna be a squared plus b squared, right? And b is 5. So we get 3 squared plus 5 squared, which turns out to be 9 plus 25, or the denominator simplified to be 34. So we write in the standard form to have the real part 3 over 34 subtracted by 5 over 34i as a standard form of the complex number for this problem.